This is section 4.1, slack variables and the pivot. In the previous chapter, we talked about and worked with solving linear programming problems by the graphical method. And this method worked for problems with two variables. But when we get more than two variables or have a lot of constraints, the simplex method is used. And so that starts with picking one corner point, and then in a systematic way we find other corner points, and finally we find an optimum solution. The simplex method requires a number of steps, and so we're going to cover the two sections in this chapter that get you going on that. For one, we're going to be able to set up a problem and the method starts. Then in 4.2, we're going to complete the method. So we will start with just figuring out how to get started and setting up a problem. In the standard maximum form, if it's in standard form, if the following conditions are satisfied: the objective function is to be maximized, all variables are non-negative, and all remaining constraints are stated in this form. Now, don't worry about that. Let's talk about what we're going to do. To use the simplex method, we start by changing the constraints, which are linear inequalities, into linear equations by adding a non-negative variable called a slack variable. Example. So we have this problem. Maximize z equals 3x sub 1, 2x sub 2 plus x sub 3, subject to. And we have these inequalities and all of these constraints. So the solution, we're going to rewrite the constraints as equations. Let me make this a little bit smaller. By adding slack variables S1, S2, and S3 for each constraint. So you look at the number of constraints, that's how many slack variables we're going to add. One for each, all right? The z is going to become the objective function that we talked about in the previous chapter. Subject to 2x sub 1 plus x sub 2 plus x sub 3 plus s sub 1. And it's no longer an inequality, it equals 150. So let's look back up here. This was these three things added, less than or equal to 150. We've still got those three things, but we added in a slack variable equals 150. Second constraint, we don't have an S1, we have an S2 equals 200. Third constraint, S3 equals 320. All right, now the equations can be written in an augmented matrix form. So we've got everything up here, x1, x sub 2, x sub 3, s1, s2, s3, and z. And we just take the coefficients, and if there wasn't anything there, it becomes a 0. And we have an augmented matrix. Remember that line is there, and the constants are over here. All right, does that make sense? Now, our objective function, this bottom line, let's look back at z. Z was 3x sub 1 plus 2x sub 2 plus x sub 3. We need to move all of that to the left. And so when we do, that became a -3, a -2, a -1. We don't have a s, 1, 2, or 3, and the z is a +1, and we have a 0 on the right. These are going to be called, and this is our objective function down here, and these are the indicators. The matrix is called the initial simplex tableau. The numbers in the bottom line row from the objective function are called the indicators, except for 1 and 0 at the far right. So everything here, these are the indicators. Reading a solution from a simplex tableau. You have a solution if you have zeros everywhere and a constant one place. So in this solution, the variables x2 and s2 are basic variables. Their columns have all zeros except for one non-zero entry. Do you see the difference between these? This is all zeros and a 2, all zeros and a 5. All variables that are not basic have the value 0. So these are the basic ones. The others are not basic and they have the value 0. So if we were going to read the solutions, here we have 2, let's see if we can see this as well, 2s sub 2, 2s sub 2 equals 17. And we solved that. So s sub 2 must be equal to 17 halves. The x sub 2, 5 of these equals 45. We solved that, so x sub 2 equals 9. On the z, we have 3z equals 90, so z equals 30. The total solution, everything else is a 0, but we did find 9, 17 halves, and 30. Okay? All right, let's see if we can make this a little bit different. And so now we're going to bring in the idea of a pivot. Getting a solution from an initial Tableau is really, it doesn't happen very often, and it's necessary to proceed to other solutions. So to get those other solutions, we use restricted versions of the row operations that we did in Chapter 2, and we change the Tableau using one of the non-zero entries of the Tableau that we call a pivot. And the row operations are used to change those other items in the column to 0 except for the pivot itself, which remains unchanged. So we'll see that in the examples that we're going to do in the problem set. Let's move towards that. Okay, number 1, convert the following inequality into an equation by adding a slack variable. So this is a piece of some problem. So we had 5x1 plus 4x2 minus 6x3. And if we were going to add a slack variable, plus s1 equals 105. Remember that when we're changing it, we're making it an equation rather than an inequality. So that would be choice C. Number 2, determine the number of slack variables and name them. All right, so here's our problem. There's our objective function. We have how many constraints? 1, 2, 3. So since we had the 3 constraints, there are 3 slack variables named S1, S2, and S3. All right, assume the first equation uses a slack variable is 9x1 minus x2 plus s1 equals 180. What is the second equation? Well, that means we're going to take this second one, 11x sub 1 plus 6x2 plus s2 equals 217. That's choice A. What's the third equation? 12x1 plus x2 plus what are we going to add? s3 equals 342. So that's choice C. Okay. For the given maximization problem, A, determine the number of slack variables. How many constraints do we have? We have 1, 2. So 2 slack variables. Which slack variables should be used? They're not x's, it's s1 and s2, so that's B. What is the equation using a slack variable? I don't know why that will not, there we go. That corresponds to the first constraint. So if we look back at the first one, it should be 8x1 plus 4x2 plus 10x3 plus s1 equals 173. So that is that one. And what's the equation for the second constraint? And here it is. So it would be 3x1 plus 5x2 plus 12x3 plus s2 equals 221. Okay? All right, number 4, introduce slack variables as necessary and then choose the initial simplex tableau for the problem to the right. So here's our constraints. and here's our z. So we got two constraints, so we need S1 and S2. So we would have 4, 5. So here's your x1, x2, s1, s2, and your z. Okay? So you've got 4, 5, 1, 0, 0, 20. 5, 1, 0, 1, 0, and 20. We move everything over here, so z minus 3x1 minus x2 equals 0. So we've got -3, -1, 0, 0, 1z, and we got 0 on the right. That makes sense. This does not work. Okay, so it is this one. Introduce slack variables as necessary and write the tableau. So here's what we're maximizing. We're subject to here. So how many slack variables do we need? 1, 2, 3. So x1, x2, s1, s2, s3, z. So we're going to put this in. 1, 2, 1. That would be a 0. 0, 0, 14. Next one, 7, 1x2, 0 s1s, 1 s2, 0, 0, and 8. Third one, 9x1, 2x2, 0, 0, 1 s3, 0, and 7. These moved over, so that's a -1, a -4, 0, 0, 0, and a 1 and a 0. Okay. Write the solutions that can be read from the matrix. All right, so if we're looking at this, we look for where we have one non-negative number and the rest zeros. So we've got something here and something here. Well, I don't know why those are not writing. Okay. And now they decide to come. Technology is great, except when it messes up. So I'm going to put a check there and a check there and there. Those are where we have to actually solve. x1 is going to be 0. x3 is going to be 0. s1 is 0. All right, so on x2, we have 1x2 equals 10. So x2 is 10. On this, we have 1s2 equals 15. So s2 is 15. And then we have 1z equals 17. No dividing needed here. So that was how we filled in all of these zeros or the numbers. Number 7. Find the solutions that can be read from this. So x1, that's going to be 0. x2, okay, we have all zeros and a 2. So 2x2 equals -12, sorry. So x2 is -6. All right, x3 is all zeros in that. So we have 13x3 equals 52. Go and get that value. So x3 is equal to 4. All right. S1 is going to be 0. S2 has all zeros and a 2 there. So 2s2 is equal to 6. So s2 is equal to 3. All right. S3 is going to be 0. And then z, we have 2z equals -24. So z is -12. And that's how we filled in that. So I think we are ready to set up a problem, and then we'll continue in the next section on solving.